Hi guys, in this video we're going to be looking at the vector equation of a circle. So obviously we need to have a circle, we need to know its center, and I've given this circle the center with coordinates AB, and I've given it a radius of capital R, and that's just to distinguish between the radius of the circle and the position vector R that we've been looking at so far. So what do we want? We want to find an equation in terms of R that defines every point around the circle. Trying to find every vector R that defines the circle here. And what should be fairly obvious is that the distance of all of these points around the circle to the center of the circle should be the same, and that's the radius R there. So to do this more formally, let's write the center of the circle with a position vector of a lowercase c, and that means that we can actually write the just get a pen out here. We can write this vector here as r take away c, okay, and that's the vector going from c to r. So that's that vector there. So we're going to go up c, we're going to go down here, and that's going to give us this vector r over here. And we know that the length of r take away c, we know that the length of this dotted line over here should be the same as the value of r. So what does that mean? We know that the distance of r to the center of every point around the circle must be the same, and it must equal the radius. So the modulus brackets, the way I like to use modulus brackets is I talk about distance. The distance of any point r to the center of the circle, C, must be R. And only those points that satisfy that equation will form that circle with center AB and radius R. We also need to be able to write these in the Cartesian form, and we should know from year 10 that in Cartesian form, the equation of a circle centered at AB with radius capital R will be x take a squared plus y take b squared equals r squared. And those are the only two equations that we need to know with regards to circles. The ideas with spheres, which we'll cover later on, are going to be exactly the same, except we'll just have a z take c squared in the Cartesian equation, and the vectors will just have 3 components instead of 2 components in the two-dimensional cases like we have with circles. So let's do a few examples now, and that's important, so copy that down. Example 1, determine the vector and Cartesian equations of a circle with center 5, -3, and radius 4. Hey, well, we just learned that we can write any equation of a circle like this. So we don't know what r is, but we want to find all the points r where the distance of r to the center. So the center is at 5, -3. And we want them all to have a distance of 4 or a radius of 4. And so that'll give me the circle that I want. And it'll look something like that. And then every point on that circle can be satisfied with this equation over here. The distance of r to the center must equal 4. Because if it doesn't equal 4, if I'm finding that distance there, then it's not going to be a point on that circle. Alright, so now we have to figure out what the Cartesian equation is. So the Cartesian equation is pretty easy. You don't need to go through any elaborate processes. You should just know the formula, that it's going to be x take away 5 squared plus y take away -3 squared equals 4 squared. And we'll make that look a bit nicer. X take away 5 squared plus y plus 3 squared equals 16. Usually I would write it straight in the second way that I've done over here, but I'm just showing you that be careful with your negatives, because 2 negatives will make a positive at the end of the day, and don't forget to square your r value there. Alright, so determine if the point 4, -2 lies on the circle with the equation r take -2/3 equals 3. Okay. So if it does lie on the circle, then if I substitute it into the equations, we'll substitute 4, -2 in for our r vector. So if we find the modulus of this, if that does equal 3, then it is a point on the circle. So let's not get ahead of ourselves. 4 take away negative 2 is 6. Negative 2, negative 3 is negative 5. And the modulus of that is going to be the square root of 36 plus 25. And that's going to be the square root of 61. Okay, and that does not equal 3. Now, the square root of 61 is actually bigger than 3. So because the square root of 61 is greater than 3, that means that this point here doesn't lie on the circle, it lies outside the circle. Okay, because if it did satisfy on the circle, it would have equaled 3. If it's inside the circle, the modulus, so the distance of the vector to the center, will be less than 3. So I'll just put that on there now for you so you can see what that looks like. I'm just going to get red. Okay, so if it was inside the circle there, obviously the distance of that point to the center of the circle is less than the radius. Our point, the 4, negative 2, was over here somewhere. Okay, and obviously the distance from this point to the center of the circle is quite large. So it's greater than 3, so it's outside the circle. And if it was on the circle, the distance from that point to the center of the circle would equal 3 exactly. So in this case, because we had root 61, that's greater than 3, so our point lies outside the circle. So let's look at the third example. We want to determine the minimum distance between the circles with vector equations this and this. Now for a lot of these questions, I like to just draw a quick picture of what's happening there. So I'm just going to draw 2 circles like this, and I'm not saying that they're the same size or anything like that. If we want to determine the minimum distance between the circles, we want to travel in a straight line towards the circle. So what we need to find is that distance over there. So we know where this circle is, we know where the center of that circle is, we know where the center of this circle is. We also know the radius of the first circle, we know the radius of the second circle. So to find that distance there, it's actually not too hard. All we need to do is we need to find the modulus, or the distance between the 2 circles. So we want to find the distance from that center to that center of the circle first. And that's going to give me the modulus of negative 2, negative 5 is negative 7. 3 take away negative 1 is 4. And the modulus of that is going to be the square root of 49 plus 16, which is the square root of 50, 64, 55. So the distance from the center of the first circle to the distance to the center of the second circle is root 65. So we've worked that out. We know what R1 and R2 are. So the distance between the circles is going to be that root 65, take away the radius of the first circle, take away the radius of the second circle. And that's going to give you some root 65, take away 5 as an exact value there. You can type that into the calculator and get the decimal values if you wish.